Alright, what's up everybody? So, last time we talked about absolute values. And then today we're going to be talking about... Gotta make a pen. Today we're going to be talking about the aCosine, which is actually the same as arcCosine. So I'll explain what that is now. Cosine. Right? And so what is arcCosine? Well, that's the same as the inverse of cosine, or in other words, it's kind of like the reverse of cosine. So let's actually throw this down. And then let's get this guy. Alright, so if we go over here, we can say, okay, so what is arcCosine? So we have arcCosine, right? Cosine. So that is the same as cosine negative 1, like that. And generally it's with like whatever. Generally it's with a variable known as theta. That's kind of very poorly drawn. Let's draw it again. It's kind of generally something like that, like a circle, and like, yeah, something through that. Or maybe it's like that with a line. Doesn't really matter. Some degree is generally what goes into a cosine, right? You'd put some degree in there. All right, so that's can generally just be between 0 to 360. Although after 180, kind of repeats itself. And the reason of this is something called the unit circle. Circle. I think that's how we spell. So pretty much, I don't, fully remember it off by heart anymore. But you can easily search it up to, kind of give you a better idea. But in terms of arcCosine, right? What does that mean? What are we doing, right? So can't draw on that. Can't draw on that. You know what? Let's do this real quick so that we can fix this. I'm like 90% sure it is. Oh, come on. There we go. I think it's too close into the wall. So if we just pull that out a little bit, we pull that out. Let's pull this one out. Like that. Doesn't really matter. So what is arcCosine, right? So if we're talking about it logically, it's cosine of an x, which equals some theta. Okay, so what that means, like practically speaking, is okay. In terms of cosine, the x can be greater than or equal to, right? So this is greater than sine, equal to sine. So it can be greater than or equal to negative 1 in terms of the cosine of negative 1, right? I mean, sorry, arcCosine. So x can also be less than or equal to positive 1. So that's kind of its range, right? So what that means is when we're going to go to the circuits in a little bit, the possible inputs will be integers between, not integers, floats, which is pretty much just a number that is like a decimal, right? So like that's an integer, but like 1.0 is a float because you're going into the kind of like decimal range. And I'll go more in depth in that another time, but pretty much, I'll take that out there. Pretty much we say, okay, we know that x can be less than 1 or equal to 1 or greater than -1 or equal to -1. So that's going to give us a theta. And once again, because of the unit circle, if you look at the unit circle, it's pretty much saying, you know, here's, let me just do it over here. It's pretty much saying 1 and -1. Not that we need to go into it, but pretty much the cosine is the x, and then the sine is the y. So it's, if you wrote a little thing like that, it goes 1 that direction, -1 this direction on the x-axis, right? But pretty much we have 1, we have -1. So what the theta is going to be is in a range between here. So what does that mean? Well, that means it's going to be between, theta is going to equal pretty much theta is going to be less than or equal to and greater than or equal to. So theta is going to be less than or equal to 180 because, sorry about that, because 180 degrees, because we have a line and that angle 180 degrees. And then, you know, what if it's over here? Boom, that's 0, right? So what does that mean? Theta can be 0 all the way up to 180, dependent on what our x is, in between 1 and -1. So logically speaking, we are finding, if we're talking about the unit circle real quick, logically speaking, we're giving it an x and sometimes a y. We're kind of like finding that outer angle, right? If you want to go into those specifics, though, I would definitely look at like some Khan academies, things like that. They're definitely great for learning about trigonometry and different geometry. It's called Khan Academy. Yeah, the Khan part is really the identifier there. So now we're going to drop that. We don't care about that. We've learnt the rough, you know, what is it doing? What is it actively changing, right? And what can we input? So now if we actually go over to it, we say open palette, we say circuits, a cosine. We go over here, click the cosine. Very similar to our absolute value thing. I thought we could squeeze through, but we can't. So pretty much we can just go open palette. And actually, we don't even need to do anything. We can just show you how to do it without a event. But first, we're going to click configure, right? Go in here. Generally, good rule of thumb, if you don't know what you're doing or if you're trying to do something and you don't know where it is, click configure, click on the thing. Any more options? In this case, no. I thought there was, but there's not. So we're going to quickly click wire. Then we're going to go, okay, so our float, remember we said that's similar to an integer. It's just got, you know, decimal points behind it. That is 0. and our result is 90. Okay, so where on here, right? If we look at that, we drop that. If we look at this unit circle, when our x is 0 right here, right? We've got so finicky. We've got x and y. All right, so that's our x. So when x is 0, we have a line going up like that, right? Like that. It's a bit easier to see going down. So our degree for the angle is 90. It logically makes sense. You can definitely go online once again, look at all of that. But if we look at this and we say, okay, well, before we type it in and mess with stuff, going off of logic, what do we know? Well, we know that 0 is 90, right? Well, what is 1? Okay, what is it when x is over here? If this is 90, what is that, right? Where does this so-called line get dragged down to? So if it's getting dragged all the way down there, presumably our angle should be 0, right? So if we type in number 1, double, there we go, and our float is 0, which is representing the degree. So one more test and then we can pretty much be done with this. We'll say, okay, we've done -1, we've done 0, I mean, we've done 1, we've done -1, 0, let's do -1. Well, let's have a look at it. Logically speaking, -1 should be 180, right? Because that's our maximum bound, and we know that theta can go to a maximum of 180. So let's look. Boom, 180. So we've got our range, we've got all that, and we kind of get the idea. And using the unit circle and kind of, if you're looking for different uses, just kind of like look at the unit circle and search that type of terminology up to help you see like what different values of x you can use, right? You can use things like 1/2. You can go like √3/3, but that might be the radians. I forget. Pretty much, a cosine, you're able to plug in these values, and it gives you a range between there based on the unit circle, right? So just to reiterate, arc cosine is a cosine, because it's not super clear. It just says it allows you to use the a cosine. So a cosine, arc cosine, if you're looking it up online, it can also be cosine -1 of, some number, and that should give you some degree. All right, well that's been the arc cosine. Yeah, thank you so much. I would have a look online, see different uses for trigonometry. There's some great things you can do for determining how far something is using right triangles. If you know how far it is based on like your x coordinate, but you don't necessarily know how tall it is, right? You can calculate that, and you can do all these really cool calculations to help you with things. But in this game, there is a rangefinder, so I don't know. It's definitely useful tool to use. Anyway, yeah. Thank you so much again, guys. If you liked it, let me know. If you think I missed anything or you're confused about any of this stuff, because it definitely can be confusing sometimes, let me know, and then I'll be sure to try and help you out. All right, thank you so much.